exponentials, we really prefer base of e to the x, because the derivative of e to the x is still e. When you have a different base, the derivative of any other exponential function, the derivative is still that number to the x power, but times the natural log of it. So for instance, if my function was 5 to the x, the derivative is 5 to the x times the natural log of 5. We were really doing the same thing with e, derivative of e to the x. If we follow this rule, it's e to the x times the natural log of e, but what is the natural log of e? 1, so that's why we were able to say that one was just e to the x. So if your base is anything else, you just have to throw a natural log of the base on there. So for instance, if I ask you to find this derivative, so we have to do our chain rule here. We have the exponential piece, so it's still 3 to the power. Because my base isn't e, we need a natural log of 3. That's the derivative of the outside. Times, what's the derivative of the inside? The derivative of the exponent? Just 4. Really not much you can do here. You can reorder things if you wanted, but it's all equivalent. So it's just 4 natural log of 3 times 3 to the 4x plus 1. I want you guys to do b. So the derivative of 8 to a power, you still have 8 to that power, times the natural log of the base, times the derivative of the exponent. So just -6 natural log of 8 times 8 to the 7 minus 6x. We get that? Okay. Let's just practice a couple more. So these are more review type problems. How many functions do we have here? Sine, a cosine, and a tangent. So we have 3 functions. That means we have to do the chain rule more than once. Okay, so we start on the outside. What is the derivative of the outside? Cosine. So, my derivative, f prime of x, derivative of the outside, derivative of sine is cosine. The inside stays the same. So cosine of tangent x. Times. We are working our way in. We have to do the derivative of the inside. So, what's the derivative of cosine? Negative sine. Inside stays the same. Times. We have to keep working our way in. Derivative of the inside. What's the derivative of tangent x? And I know that was the last one because now my inside is just x and the derivative of x is 1. As far as simplifying here, really the only thing I would ask you to do is pull that negative out in front. So just negative cosine of cosine tangent x times sine of tangent x times secant squared x. Last problem for today. I'm not sure why my theta kind of dropped down there, but it's e to the secant 3 theta power. So derivative of e to the power is have to do times the derivative of that exponent. So what's the derivative of secant?
Secant tangent.
Secant 3 theta, tangent 3 theta. Okay, my inside still isn't just a plain theta, so working our way in, what's the derivative of 3 theta? Okay, again, not much I expect you to do. I just would prefer that coefficients get pulled to the front. So 3e secant 3 theta times secant 3 theta tangent 3 theta. So